Want to make a comeback in chemistry paper 2? Then make sure you know your practicals. This is what you need to know about the rates of reaction practical. This practical split into two parts. First, measuring the volume of a gas produced, and second is observing changes in turbidity. That's the disappearing cross practical. Let's start by focusing on the volume of gas. Nice and simply, we react marble chips with hydrochloric acid. If you do this, you'll produce carbon dioxide gas. Then we collect and measure the volume of carbon dioxide gas produced either using a measuring cylinder or by using a gas syringe. Fundamentally, it's so important that you also measure time when doing this, because the rate of anything is how much that thing happens per a unit of time. So when measuring our volume of gas, we do so at regular time intervals. The underlying purpose of this investigation is to see how the concentration affects the rate of reaction. So we simply just repeat this whole process with many different concentrations of that hydrochloric acid. Don't forget, to ensure that we get valid results, it's really important that we control everything else that could have also affected the rate of reaction that is not that concentration which we're changing on purpose. So that would include the temperature, the mass of the marble chips we use, and also the volume of the acid we use. One last consideration, make sure you're starting your timer the instant that you mix together those marble chips and the hydrochloric acid. And make sure you're quickly inserting your bung or putting it under the measuring cylinder to ensure that none of your gas escapes and is not measured. That was the reaction with gases. This is how you do it, observing changes in turbidity, which is referring to how clear your solution is. For this, we mix together sodium thiosulfate with hydrochloric acid. Over time, this will react to produce a cloudy sulfur solution. We do this reaction in a conical flask and then place that conical flask on a nice white tile with a really clear, bold black cross. You then just simply time how long it takes for your black cross to disappear because your solution has turned cloudy. And you can then calculate your rate by doing 1 over the time. Effectively, the greater amount of time means the slower rate of reaction. Faster time for your cross to disappear is faster rates of reaction. Then we just repeat. And then just like before, the reason we're doing this is to see how changing concentration affects your rate of reaction. So just simply repeat that whole process using different concentrations of sodium thiosulfate. And consider your control variables, everything else that could also affect the rate of reaction that is not the concentration which we're changing on purpose. That includes the volume of our solutions we're using, the same exact type of cross on the tile, the same lighting, and ideally the same person observing the disappearing cross each time. And that's all you need to know. If those show up now, you're going to be buzzing. Make sure you save this so you can watch it again before your exam, and I wish you the very best of luck.